All right, to kind of wrap things up and to, well, I'm going to meet that, to add more confusion is the term agents that is used in chemistry, in redox chemistry. Now, this is about the chemistry special agents. And basically, it's a lingo that is used, or vocabulary that is used by chemists to kind of say that, oh, I don't want to, I'm too lazy to explain that what is oxidizing and what is reducing. So I'm just going to paraphrase everything by adding the word agent to it. And you probably like going like, what the hell is he doing and what is it going? Well, basically, it's trying to explain that what is this doing to this, or this doing to that, or that doing to this, and this doing to that. Like, who is actually giving out the electrons, and who is actually taking the electrons, and who is gonna like make the big bang out of things. All right. So we're gonna go and do the same process for what we've been doing so far: assigning oxidation numbers, figuring what is reduced, and then adding who is the oxidizing agents or who is the reducing agents. But before we get started, a couple of definitions that you should know. Boom. What is a reducing agent? A reducing agent is something that oxidizes. That, right? If you have something, an agent here that oxidizes something else, this is a reducing agent. Now, if you have an oxidizing agent, this oxidizing agent reduces something else. I know the name is complicated and it's like pulling your hair out. It's like, what? Not only is losing or gaining electrons counterintuitive because I'm gaining electrons, but I'm reducing, and then I'm losing electrons and I'm oxidizing, and then what is oxidizing and what is reducing, and then now I have to add these agents to it? Oh, yes, it's that confusing. And I will admit, I had all this confusion when I first started learning it. But there's no way around to this old system of how we learn stuff. So we might as well just accept it and, yeah, do it blindly. And then just be able to answer questions. Okay, so here we go. So here we have a chemical equation, and we're trying to figure out what's going on with the electrons right here. Who is making the electron cache? Well, first step, assign oxidation numbers. So I'm just going to look at this and say, hydrogen here always has a +1, except if it's a metal hydride. This is not a metal hydride. It's just a regular hydrogen bonded to covalently bonded to a carbon. So it has an oxidation of a number of +1. There's 4 hydrogens here, so it has a total charge of +4. Then what should the oxidation number for this carbon be? -4. Oxygen here is neutral, is an element, so it's an oxidation number of 0. Carbon dioxide, well, here each oxide is a charge of -2. The carbon here should be a +4, right? Because there's 2 oxygens, so that makes it -4 charge. And to neutralize it, carbon here has an oxidation number of +4. Water here is a -2, here is a +1. Oxidation numbers, really easy peasy. Okay, now we're going to figure out what is being reduced and what is being oxidized. Well, let's take a look. Carbon is changing from -4 to +4. All right. This guy here, hydrogen, hasn't changed its oxidation state, right? So here is +1, here is +1. So it's not actually doing anything, all right? It's not a spectator ion. Remember, we've worked with problems like that. It's not. It's just not doing anything. It's not really contributing to the pool of electron cache. But what about oxygen here? Oxygen is converting from 0 to -2 here. So it is doing something. So let's figure it out. Okay, we're going to split the equation into two halves, right? And we're going to try to figure out what is going on with this one. Okay, so carbon minus 4 becomes a plus 4. All right. And we have oxygen, that is a 0, becoming oxide. All right? So, what is happening here? I'm not going to try to balance the equation because it's with electrons, because it just kind of looks weird. You're not really supposed to do it here on a piece of paper, but I'm just using it to kind of explain it to you what's happening. Okay, so here we go. When you go from a negative number to a positive number, you're basically losing electrons because you are becoming more positive. Okay? Because when you lose electrons, that means you lose your negative numbers. When you lose negative numbers, your numbers become more positive. So you're definitely losing numbers. So you can say that this is oxidizing. Right? Carbon is oxidizing. It's oxidized. And so what agent do we call carbon here? This is our reducing agent. Alright? It's oxidizing, it's oxidized, and it is also our reducing agent. Why? Well, it's because it's reducing something else. What is it reducing? This guy, oxygen. Oxygen here goes from 0 to minus 2. So it is actually it gains electrons, right? Because you're going from a bigger number to a smaller number, from 0 to minus 2, so you're adding 2 electrons. So definitely we say that this guy here is reduced. And what is our oxygen here? Well, it is the oxidizing agent. Okay? So it's basically, when you answer the questions on your exams, or whatever have you have like, what is reduced? You figure that out, what is reduced and what is oxidized. And then when you add the word agents to it, you just flip it around. So whatever is oxidized must be the reducing agent, because it's going there and oxidizing everyone else. And then we have oxygen that's being reduced. And what is it? What kind of agent it is? It's the oxidizing agent. It is reducing everyone else. So there you go. That's the concept of the chemistry special agents. It is confusing. You need practice with it. But that's a good thing. We'll have plenty of time to do that in class. Well, not plenty of time.